Today, we're going to peel back the curtain on something we do a million times a day without a second thought: sending something, anything, across the internet. It's this invisible, almost magical journey, and when you see how it works, it's really fascinating.
I mean, it really does feel like magic, right? You click a button, you tap your screen, and a message or a photo or, a request for a website just appears somewhere else in the world. But between that one little action and the final result, there's this incredible, completely silent journey that takes place. So today, let's trace its steps.
Okay, so this gives us a great bird's-eye view of the whole trip. I want you to think of it like a digital postal service. Your device sends out a request. It travels through this massive network, the internet, all the way to a server, and then that server sends a reply all the way back to you. Our mission today is to understand each stop along this route.
So where does a journey like this even begin? Well, like any trip, it has a starting point. And for the internet, that starting point is a place called the network edge.
The things that live on this edge are called end systems, or hosts. And this isn't some abstract technical term. It's literally the device you're using to watch this right now. Your laptop, your smartphone, and even the servers that hold all the websites. They're the starting blocks and the finish lines for all online communication. The very first spark of this whole thing happens inside an app. So, when you type a website into your browser and hit enter, that browser creates a message. It's basically a little digital note that says, "Hey server over there, I'd really like to see the contents of this web page, please." This little message, that's the precious cargo that's about to go on a very long trip.
Okay, but here's the thing. You can't just send that note out into the world by itself. It needs to be packaged up properly, it needs an address, and most importantly, it needs to be written in a universal language that every single stop along the way is going to understand.
And this shared language is all about protocols. Now, don't let the word scare you. A protocol is just a set of rules. It's like grammar and etiquette for machines. It makes sure that when one computer sends something, any other computer knows exactly how to receive it, how to open it, and how to read it correctly. It is the absolute foundation of everything we do online.
Now, here's a really smart part. The internet doesn't try to mail your whole message in one giant box. Instead, it chops it up into these little numbered pieces called packets. It's kind of like if you wanted to mail a 1,000-page book, but you sent it one page at a time. It sounds weird, but it makes the whole system way more efficient and a lot less likely to fail.
And this is how each of those tiny packets gets ready for its trip. You can think of it like getting dressed in layers. First, at the application layer, the message itself is written. Then, the transport layer wraps it up with delivery instructions. Next, the network layer slaps on the final destination address. Then, the link layer adds directions for just the very next stop on the journey. And finally, the physical layer turns the whole thing into light or electrical signals to send it on its way.
All right, our packet is all dressed up and ready to go. It leaves your device, and now it enters the heart of it all, the massive, complex network core.
In this image is a perfect way to think about it. The network core isn't one single thing. It really is a network of networks, a huge, sprawling system of interconnected digital highways that crisscross the entire globe.
So how on earth does our tiny packet navigate this insane web of highways? Well, it relies on these special devices called packet switches. You probably know them by a more common name: routers. A router is basically a traffic director at a super busy intersection. It looks at a packet's destination address, and in an instant, it decides which road to send it down next to get it one step closer to its destination.
And routers do this job using a method called store and forward. What that means is the router patiently waits to receive the entire packet, it does a quick check to make sure everything looks okay, and then it forwards it along. It's this very careful step-by-step process that makes sure our data stays intact as it hops from one router to the next to the next.
This kind of brings up a huge question, right? You've got billions of these packets flying around the digital highways at any given second. How is it even possible that they can all share the same roads without it just turning into total gridlocked chaos? What's the secret?
Well, the answer comes down to a really important design choice. See, old-school networks, like for telephones, used something called circuit switching. That's like making a reservation at a restaurant. A private lane is opened up just for you, which is great, but it's super wasteful if you're not talking. The internet, on the other hand, uses packet switching. This is more like a restaurant with no reservations. You don't get your own private table. Instead, you just merge into traffic and share all the resources really efficiently with everybody else.
And that is what makes the modern internet we know and love actually possible. Because resources are never reserved, they're never wasted. The highways are used only when a packet actually needs to be sent. It's such an elegant idea, and it's what allows billions of us to share the same network all at the same time.
So our little packet has made it. It navigated all those digital highways, and now we get to the final and honestly kind of the most beautiful part of this whole journey, the quiet collaboration that brings it all home.
So after hopping across who knows how many routers, all those individual little packets that made up our original message finally arrive at the destination server. There, they get checked one last time, they're put back into the right order, and they're all seamlessly stitched back together into the complete message. And just like that, the web page appears on your screen. A journey that could have crossed the world, completed in less than the blink of an eye.
So, let's do a quick recap of the main characters in this story, shall we? We had the end system, which was our starting line and our finish line. We had the packet. That was our little piece of digital mail. The protocol was the shared language, the rules of the road that made it all work. And the router was our traffic director, guiding the way at every single intersection.
You know, if you take one big idea away from all of this, let it be this. The internet isn't a single thing. There's no big red button in a control room somewhere. It works because it's a massive, quiet, and beautiful collaboration between billions of independent parts that have all just agreed to speak the same language. And that's exactly what makes it so tough and resilient.
And that brings our little journey to a close. It's a pretty humbling reminder that just beneath the surface of all our simple, everyday clicks and taps, there are these incredibly elegant and complex systems just quietly working away. And it leaves you with a nice, peaceful thought to ponder. What other invisible journeys are happening all around you right now?